Parallel pumps benchtop test sets product launch. I'm sorry for the short delay. We had a few technical difficulties, and now we are ready to roll. My name's Dion Knowles, and I'm the marketing manager here at TecQuipment, and I'm joined by Jack Rawling, our mechanical engineer. Hey, Jack.
Hi.
Over the course of the next 5 to 10 minutes, we'll be taking you through our latest new product, the Variable Speed Series and Parallel Pumps Benchtop Test Set. You may be familiar with this product. For those people who are very close to the TecQuipment product range, that is because this is based on market-proven technology from a product that we launched in 2019. Before I get onto that, I want to just shout out to a few people. We've got Shisti Traders online from Pakistan. Also, we have got Tim Whitehouse from the UK. Elamu as well has joined us. Thank you very much for putting your names on there. And now I would like to remind you that I will be looking at the comment box throughout the course of the live stream. So if you have any questions, please pop them in there. Have to be patient with me. It may be that Jack is immersed in a description and I have to wait until the very end to ask his question. If we don't get to all of your questions during the course of the live stream of the video, then we will put them in the comment box below for you to look at afterwards. Right, let's put that one down and let's get on with the demonstration. This here is the Variable Speed Series and Parallel Pumps Benchtop Test Set. This particular product is for understanding the characteristics and behaviours of two cavitation pumps used both in series, no, not cavitation pumps. This is something I keep getting mixed up. Centrifugal pumps used both in series and parallel. As I mentioned earlier, this is based on market-proven technology. It's similar to a product we launched in 2019, the Series and Parallel Pumps Benchtop Test Set. But what we've done with this particular product is we've integrated more functionality for more advanced learning outcomes. As you can see, it's a benchtop-based unit. It does not require extra services like a drainage or a water supply, and it has a standard power supply. It's pretty much plug and play, quick to use as well. So, Jack, you're the mechanical engineer. Please do walk us around this product and tell us more about the new functionality and how it all works.
Okay, so we have water tank. As Dion says, you don't need mains water supply. We've dyed the water blue in this case, so you can hopefully see a little bit better what's going on. We have a series of valves, 2 inlet valves, a couple to change the setup from the pumps from series to parallel, and a delivery valve. We have 2 inlet electronic pressure sensors, 2 delivery pressure sensors, and a electronic flow meter. That has a built-in temperature sensor as well, and there's a temperature probe in the water tank.
Brilliant. Good stuff. Right, well, do you want to get this up and running?
Yep, sure. Shall we set it up in parallel?
Yeah, fantastic.
Okay, so parallel, we want both inlet ports open. We want to close the link between the two, and we'll leave the delivery port open while we get it up and running.
Right. Oh, before you turn it on. Okay, you have turned it on. Before we get it running, why would you want to use it in this setup in the real world?
Okay, so running the pumps in series rather than parallel is going to get us an increased flow rate, and you would potentially use 2 pumps rather than say like a single pump, because it's going to gain us some redundancy. So you know, if we had 1 pump and 1 pump should fail, we're down to no flow rate. But here we have some redundancy, and also it's situational, but you may have a situation where you have just a standard flow rate that you require to maintain all of the time, and then you want to have a boost in a little bit of flow rate later on for a particular reason. Okay,
great. Let's see it running.
There we go. We're up to speed.
Okay, good stuff. Right. Let's put it in the other formation, shall we?
Yep, sure. So we'll leave it running, and we will set it up in series. So from pump number 2, we want to feed into pump number 1. We'll close this port here so that that one can't suck from the tank, and force the water to go down there. So there we go. Now we're running in series.
Great. And did you mention to me earlier that we could throttle it using this valve?
Yeah, sure. So there you go. You can hear the pumps. We're making them work a little bit harder there.
Sound out there. Okay, great stuff. So perhaps we could turn it off a second while I ask you a question.
Would you like to see some cavitation?
Oh,
maybe?
yeah. Before we turn it off,
bit of that.
go on then.
So this may reduce the life of your pump. So this is like the situation you want to avoid when you're designing a system.
Obviously, we wouldn't recommend doing this very often because it does put pressure on your pumps, as Jack says.
Yep.
There we go. Cavitation done. Wonderful. Bit of a repetitious question, but in this setup, how would you use that in the real world?
So same situation where you've got some redundancy there.
Yeah.
You might have limited space, or so two smaller pumps might fit into the area you've got available. Sometimes, you might get a bit of an increased efficiency there from running one pump at its most efficient and having the second one switching in and out when you need to.
Okay, great, good stuff. Do you want to tell us more about the control box and the VDAS, Versatile Data Acquisition?
Yep, sure. So with this one, we have built-in VDAS, and the pressure sensors are built into the rig. And the reason we did this over, there's a difference between the H52 series and parallel pumps and the H53 is that these valves are all built in, the VDAS is built in, and you might prefer to do this rig, because this rig we can set it up so that we can automatically, take down results and data. But the H52...
You need to put your mic a bit closer. Thanks,
sorry,
Hassan.
So the H52 has board-on gauges, mechanical gauges, and a rotameter. So you take down results manually, and you might prefer to do that if you wanted, the more hands-on approach.
Yeah, okay. I've got a question here. Hassan's asked, what's the maximum pressure?
Maximum pressure? I think we can achieve 4 bar with this rig.
Okay, brilliant, good stuff. Well, we will have the data sheet online on the website shortly, so that will have all the specifications on there to answer those detailed questions as well. All right, okay, so just to summarise, with this product you can understand how centrifugal pumps work both in series and parallel. We can look at things like head versus flow, efficiency versus flow. You can do single pump suction test sets. As Jack showed us, we can demonstrate cavitation, and we can also work out water horsepower. There's some more advanced functions as well, aren't there, Jack? Tell us more.
Yeah. So
make sure your mic's nice and close.
Yeah, as Dion says, we've got hydraulic power that we can determine from the flow rate and pressure.
Yeah.
But because we have a drive powering this motor, we can work out the shaft power that motor is putting into the system, and therefore we can compare the two and work out an efficiency. We can vary the speed of that pump, so we could work out like a range of speeds versus efficiencies, work out where it's best to run that pump, get the characteristic curves.
Yeah.
Additionally, on top of that, we have a couple of thermocouples built into it, so over time you could take results and monitor how the temperature is rising, so you can see how much energy you're putting into the water.
Oh, fantastic, good stuff. Hassan again has asked another question. What pump types are we using here?
Centrifugal.
The
centrifugal pumps, but they're built in-house by TecQuipment.
Right, okay, brilliant. I hope that answered your question, Hassan. It's centrifugal, and we make these pumps here inside this building, where we make all things all under one roof. Right. Lex, I'd just like to remind everybody that we do offer a 5-year warranty on all the products, as well as manuals which have the theory, user guides, maintenance guidelines, etc. So that's it from us and the demonstration on the variable speed series and parallel pumps benchtop test set. For more information about this, then do click on the links below. That will be going live very shortly. If you want to know more about the standard series and parallel pumps benchtop test set, we have that link in the description box coming up soon as well. Don't forget to subscribe to TecQuipment's YouTube channel and click the notification bell so you don't miss any of our videos. Thank you very much. Now, before we do finally close this live stream down, I'll give it a few moments for any last-minute questions to come in. I want to thank you, Jack. How was it?
Yeah, not too bad.
Not too bad, not too bad. Well, we might be calling you back for more. Thanks to the production team who've made this happen. And thank you to you guys all around the world. Now, I gather we've got some more questions coming now. Jack, what about graph plotting? What can we do here with VDAS?
Yeah, so we can log our results and then export them via into a spreadsheet.
Okay.
We can graph them that way.
It's worth noting that all the software for VDAS is available to freely download on our website. So once you've got the control unit, then any student can put in their own laptop, download the software, and start gathering the data for themselves. We've got another question here. Are we able to control flow rate from the software or all manual valves?
The flow rate will be controlled manually via the valves. We can't do it via the software. So you're
doing that by that. Is it this that's...
This is the pump controls.
Yeah.
The valves.
Oh, right. So when you're adjusting that here, that's you're adjusting your flow rate.
Yeah.
Okay. I hope that answered your question, Alamu. Right. Well, that's it from us today. I don't think we've got any more questions coming in. Thank you very much for waiting online. I know we had a few technical difficulties at the beginning. I would like to remind you that we have another event coming up on the 20th of February. That is Theory of Machines Live, and that is a full 45 minutes to 1 hour long event where we'll be looking at the role of vibration, friction and motion in Theory of Machines, looking at practical real-life examples and how we can understand those using different pieces of teaching equipment from TecQuipment. We'll also be including a fun element into that as well. So that's all from us, isn't it, Jack?
Yep, all from us. Thanks for joining us.
Thank you for joining us, and goodbye.